Please look up. Now, we are going to look at some calculations in bioenergetics. Now, bioenergetics is actually broad, so we have different kinds of calculation in bioenergetics. So let's start with this one. Now, example 1, the energy currency of the body called adenosine triphosphate, in bracket ATP, was hydrolyzed to release terminal organic phosphate, pi, at a temperature of 27 degrees Celsius and pH of 7 in the presence of magnesium ion. It was found that delta H was minus 12.04 kilojoules per mole and delta S was plus 22.11 joules per Kelvin per mole. Calculate the corresponding value of delta G of the reaction. Now, anytime you see a calculation question like this, the very first thing you have to do is to write out the parameters given. Only that alone carries mark. So the first thing you do is parameters given. So you write the parameters. What were we given in this question? If you notice, we were given temperature, right? We are given temperature of what? So T, we are given 27 degrees Celsius. But you agree with me that in calculation, you don't use Celsius, but use what? Kelvin, right? So to convert this to Kelvin, what do? 27 plus what? 273. So 27 plus 273 will give us what? Will give us what? 300 Kelvin. Please, there's nothing like degree Kelvin. You don't say 300 degree Kelvin, it's wrong. You say 300 what? Kelvin. It's only in Celsius you add degrees or Fahrenheit. Now, the next thing, we're giving pH, but in this question we don't even need pH to solve. In the presence of magnesium ion, it was found that delta H, we're giving delta H as what? Minus 12.04 kilojoules per mole. We're also giving delta S as what? Plus 22.11 joules per Kelvin per mole. And we're asked to calculate what? Delta G. Now please take note of the units. Here the unit is in what? Kilojoules. And here the unit is in what? Joules, right? The units must agree. So we have to convert these kilojoules to joules so that the units will agree. And if we want to convert kilojoules to joules, what do? We multiply by what? By 1000. Kilo means times 1000. Milli means divide by 1000. So kilojoules. To convert it to joules, to remove this kilo, we multiply by what? By 1000, right? So we'll be having, if we multiply this by 1000, this will give us minus what? 12040 joules per mole. True or false? Is it not? Now, we've written out our parameters given. This is your first step. We can move on to the second step now. And the second step is to state your formula. In some marking scheme, that alone has mark. So you can come down and say, using the formula, this is a statement of formula. Using the formula, you state your formula now. Can I clean this side? Can I clean this area? Now, using the formula, now, look at this. We are given T. We are given delta H. We are given delta S and delta G. What formula will be suitable for this? Delta G equal to what? Delta H minus what? T change in S. This is the most suitable formula for this. Now, delta G is equal to, what's the value of delta H we are giving? Please, take note of the sign. 12, right? You are not using this again. You are using the one you've converted to joules. Now minus, we're giving T as what? 300 times delta S is what? 22.11, right? Now delta G is equal to minus, this times this is what? Please press that on your calculator. 300 times 22.11 is what? 6633. Is that all? 6633. Now delta G is equal to minus this will give us what? Minus this will give us what? Minus what? Minus 18673. Is that all? Now I told you, if you leave your answer like this is not correct, you must add your unit. So what's the unit of change in Gibbs-free energy? Joules per mole. Now this is your answer, because that was what you asked to calculate. With this, you can see you stated your parameters given, you've gotten mark for that. You stated your formula, you've gotten mark for that, and you've solved, you've gotten your full marks. But if you just come without even stating your parameters, you just start solving, you are jumping protocols. So we are going to look at a second example, but write this. Let's look at example 2. Example 2 says, in an experiment to determine the thermodynamic profile of ATP at 36 degrees Celsius and pH of 7, delta H of 20.08 kilojoules per mole and change in entropy of plus 35.21 joules per Kelvin per mole were obtained for each hydrolysis. Calculate the corresponding delta G of this hydrolysis. This is very similar to what the example 1 we did. So solution. Like I said in the first example, I said the first thing you have to do when you have a calculation question is to do what? Write the parameters. Very important. So the parameters given. What were we given in this question? We're given temperature, right? Temperature was given as what? 36 degrees Celsius. But we know we cannot solve with degrees Celsius, right? So what do? We convert to what? Kelvin. And converting to Kelvin, we are adding what? 270. So 36 plus 270 will give us what? So this is 309 Kelvin. And I've said it is not degree Kelvin, but Kelvin. Understood? Now the next thing we're given is delta H. So we're given delta H as 20, is it plus or minus? 20.08 kilojoules per mole. And we're given delta S, that is change in entropy, as plus 35.21 joules per Kelvin per mole. And what were we asked to calculate? We're asked to calculate delta G. But like I always say, when you are done writing your parameters, check the units. What's the unit here? Kilojoules, right? What's the unit here? Joules. You must make sure the units align. So we have to convert this to what? Joules, right? Now converting this to joules, you multiply by what? 1000. So this will be plus what? Joules per mole. You've converted to mole. Now we can solve now. I told you, after writing the parameters given, the next one is statement of what? Formula. So you write using the formula delta G equal to what? Delta H minus T change in S. So you've stated your formula. Now we can now substitute the values and we get our answer. So delta G is equal to, what is delta H there? 20080 minus T is what? 309 times delta S is what? 35.21. So delta G will be equal to 20080 minus, do this times this for me. 10,879 point what? So this minus this will give us what? 9200.11. Now what is the unit? Joules per mole. With this you observe everything, so your full mark will be given to you because you observe everything. So it's not about getting the last answer. It's not the last answer that is marked. All these steps have mark. Anyone you jump, you are jumping mark. All right, so write this down.